All right, today's problem is ransom note. If you haven't seen a ransom note before, they look like this. And then what you do is you have a magazine and then you just cut up the letters and then you glue them to form your message here. So in our question, they give us the message, the note that we want to build, as well as the magazine that we have to cut our letters from. And they want to know if we can actually create this note using this magazine. So I'll show you two ways that we can solve this problem. The first way is going to be easy to implement, but we can see some cases where it might not be the most efficient, and then we'll try and optimize it into our second solution. Okay, so in our first solution, we need to create some sort of an inventory of letters that we can use, and then as we build our ransom note, we're going to go into our inventory, use our letters, and then if our inventory is empty, then that means we can't create this message. So like yesterday's problem, we'll use an array instead of a hash set because we're lucky that it only requires lowercase letters. So let's have our inventory. 26 letters. And then what this does is, for example, a at 0, let's say it equals 3, that for inventory at 0 equals 3 means that we have 3 letter A's to use. So that's the mapping that we're going for. Okay, so let's read our magazine. And then inventory at C++. Now that's what we'd like to do, but what happens is this C gets converted from its character to its decimal. So you can see here in our ASCII table, here's the decimal format and here's the character. And then for a small a, it has a value of 97. So what that means is this, let's say it's A, actually gets converted into inventory at 97 plus plus. Now, of course, we don't have 97 to index into because our size is only 26. So what we want to do is we want to offset it by the letter A itself. So that means something like A minus A, this becomes inventory at 0. And then if you replace this with B, so if we read B, then this becomes inventory at 1, which is what we want. Okay, so now that we have our inventory, we're going to start building our note. So if our inventory at this letter is empty, then that means that we didn't have enough letters to create the note that we want. Otherwise, we are going to use this letter from our inventory, and then so we'll subtract by 1 to say that we used it. And then if we were able to complete all of this, then that means we built our letter successfully and we return true. Okay, let's give this a go. Cool. So you can see here that our runtime is going to be O of M here. So M is magazine length. And then here it's O of N, where N is our note length. So in total, we have O of M plus N. Now for the worst case, this is the best that we can do. So the worst case meaning we can't build our note, then no matter what, we have to read through our entire magazine to come to the conclusion that we can't build our note. But what about for the happy cases where we are able to build our note? Is there a way that we can make this better? Because right now in this solution, for example, let's take our magazine to be something like this. And then our ransom note is just ABC. We're reading this whole magazine just to say that we can build this ransom note of ABC, when really that's something that we can figure out, by the third character in magazine. And so this is analogous to like if you're building a ransom note in real life, would you cut up all the letters in your magazine before building up your ransom note? Or would you kind of read as much of the magazine as you need to in order to build your ransom note? So that's the second solution we're going to try. We're going to try just to read as much of the magazine as we need to in order to build our ransom note. Okay. So one of the immediate optimizations we can do is if our ransom note is bigger than our magazine, then there's no way we can build it. So we can do a quick check at the very beginning. So let this be the magazine length, and this will be the ransom note length. If n is less than m, then we can return, or if, let's see, if m is less than n, so if our magazine is smaller than our note, then we can return false. Okay, now we just want to read through our ransom note instead of our magazine. So here we'll have int I equals 0, I plus plus. And then here, instead of using the toChar array, we're just going to use char at, because the whole point, so what toChar array does is in the background, it copies and gives you back a char array of your string. But we're trying not to read the whole string in the first place. So we're going to use char at instead of toChar array for the magazine, and then also for the ransom note. Okay, so let's read a character. So we'll have char c equals ransom note char at I. Okay, so we'll still have some sort of inventory here. And then, like before, what we'll do is if inventory for this letter is equal to 0, so we don't have any of these letters, we're going to read as much of the magazine as we need to find it out. So what will that look like? Well, let's keep track of our magazine index. So this will be magazine index. While true, we're going to find the first letter in our magazine that has the same letter as C. So this is our magazine letter. It will be magazine char at J. And then what we can do is what we'll do here is we'll do J++. This means we're going to read it, and then we're going to consume it. So now our index is the one afterwards. So if this letter is equal to C, then we can break out of here. So we found it. Otherwise, what we'll do is, since we already read a letter, we might as well track that we've read this letter so that in the future, so basically what we're doing is we're reading each letter, and then if it's not the letter that we want, we'll still cut it up anyways and put it into our inventory since we already read it. So inventory at letter minus a plus plus. Okay, so when do we stop? Well, we stop when we reach the end of the magazine. So if j is equal to magazine.length, then we can return false. That means we've read the whole magazine and we couldn't find a letter that we wanted to. So you can see here that the worst case is still the same as the first solution of O of m plus n. Okay, so let's see here. So we found the letter that we want, so we're good for this case. Now, what about this else clause? So here is if there's nothing to use, then we try and find a letter. Otherwise, we can just use whatever is in our inventory. So we'll subtract 1 to say that we read it. And this inventory is populated by this call right here. Okay, so we were able to do all of that. Then again, we can return true at the very end. Let's give this version a go. Cool. So you can see here what we've done is we're only reading the ransom note, and then we're reading as much of the magazine as we need in order to satisfy our ransom note. And this is going to give us a much better runtime in our average cases of where your magazine is very big, but your ransom note is only this tiny little letter that you want to compose out of your entire book in your magazine. Yeah, so that's it for today, and I'll see you on the next one.